Hello, I'm Neeraj. Today I will explain the concept of machine unlearning. Machine unlearning is very important these days. Actually, what happens when we train the model by mistake or by some misarrangement, we knowingly or unknowingly use some of the data having strict legal compliances. Like data may be sensitive, data may be highly private, personal. If we maintain the model trained on such kind of data, then it may result in loss of sensitive and legal information. So, to avoid such kind of scenario, we try to use machine unlearning. So, in the machine unlearning, we identify all the scenarios in the dataset which may be legally sensitive, and we remove those parts and related instances and behavior from the dataset without reducing the quality of the trained model. So we can say that repairing the trained model. But you may ask question like why we cannot retrain the entire model from scratch. Generally what happens, retraining the entire model from scratch requires a lot of resources and time. So this is often costly. This is the reason we prefer the machine unlearning concept. So before going into the detail, first of all, we will try to understand that how the traditional deep learning system actually works, how it learns from the data, and then what kind of characteristics we can use that is available in the deep learning training process to unlearn the learned part of the information. So let us start with a very simple deep learning training equation. So this represents that theta t plus 1 means what model knows at the time t plus 1 and equal to theta t. So theta t means what model knows at the previous time, means at time t. Nu is the learning rate and this is called gradient. So if we keep this part as a one side, then we say that the important part of this learning is gradient. So this is called gradient descent due to this minus sign. So DES. So this is gradient descent. And this actually helps in reducing the error or minimizing the error so that model can learn. So this is the role of gradient descent in training the deep learning model. But consider the scenario where the sign is positive. This is like that. Then what will happen? So in this scenario, the model will start forgetting what it learns because it may increase the error. If you still not understand, then I can explain like this. In the traditional deep learning process, we try to go towards the global minima. Maybe we cannot reach always global minima, but the target is to reach the global minima. And gradient descents are trying to, at every time it reduces the weight and try to reach the global minima so that we can get the model trained on the given data set. So this is the role of gradient descent. But if it is plus, means it is going in the reverse direction and this is forgetting what it learns. So this is called gradient ascent. And this concept of gradient ascents are actually used in the machine unlearning concept. Now we convert this traditional deep learning training equation where we have just learning rate plus gradient descents if I say that gradient descent is at GD, then we add new and gradient ascents, means we added a forgetting part also. So here gradient descents part is for retaining and gradient ascents part is for forgetting. That's why we need two types of data. One data set is for forgetting and one data set is what part of information we want to retain. So now we will try to understand in a step by step. This is not complete equation. This is now we will enter the first part, like how the machine learning starts. In a later part we will see that in the complete process of machine learning, how we can avoid the model drift situation also, because if you learn something and learn something, it will make the model to move in some other direction also. So first we will go through that, concentrate on how we will unlearn some part and retaining the related part. So for that we use the data set that contains the retain part and forget part, and then we just identify the batches for those, like we do in the deep learning task. Then we compute the gradient for retain part and then forget part. So once we compute the gradient, we can apply it as a combined update equation for practical unlearning. So it will be like a theta minus gradient descent part, and this is gradient ascents part. So descents part are for retaining and ascents part are for forgetting. So we are doing that. Now to maintain this scenario and to effectively train the model, we need a lot of precautions, because this is not so easy. For example, if gradient exploding or some things are happening, we do gradient clipping. We try to keep the or forget strength small, because if forget strength is very high, then generally model will be unstable. And we can also apply early stopping so that we can get the balance stage. We can apply the weight decay and trust region also to get the best model score. Now another thing is, like, you may ask question that what is the need of this part. We can only do the forgetting, but if you remove some part of, because what happens if you design some deep learning architecture like this, then you can see that there are a lot of relations, you can see, and the data stores matrix, creates the matrix for such kind of relations. If you just use the forgetting part, it will make a lot of relations in the form of unstable state, and it will totally destroy your model. This is called catastrophic forgetting. It will lose a lot of useful applications. Now this is not so simple as I said, because it contains some another things also. And now this is another thing. This is your seat belt. Means you are running a car, you are forgetting something, you are retaining something, but your model is moving somewhere away from your situations. So you need some seat belt to maintain this scenario, so that your model will not move away from much away from your actual model. So what are the meaning of those parts? So the first part, if you see, it is theta and theta 0. So theta 0 is your original, and theta is like after unlearning. So this is after unlearning. So this entire equation says that how far your model is with respect to your original model after unlearning. How to calculate this? There are a lot of ways, but the simplest one is to use theta minus theta 0 whole square. So you can use scale divergence also, or a lot of other things you can use. So this is the simplest thing I am doing. So now in this case, if you need to calculate this, then it will be just a simple. Now you will say that what is this beta? Here beta shows the strength of your seat belt. So if it is too tight, like too tight means the strength is too high, like near to 1, then model will not do anything. It will not go anywhere. And if it is too loose, then model will go at some other direction. Then after forgetting, your model will be something, some other model than the previous model. So this is the role of this is very important. This actually prevents model from collateral damages. So now this is like your forgetting strength. So how fast you forget. So if it is too fast, then you will lose everything. So that you also have to manage. You can say that 2 beta minus theta 0 in place of this part. So now this is the complete equation. So this part is retaining, sorry. So now this equation is a complete equation. This part is retaining, this part is forgetting, this part is to balance your model or avoid to deviate from the actual task. So this is the complete equations generally we use for machine unlearning. Now we will go through in more detail. So the complete task is like remember or retain minus forget plus stability, and you have to optimize, like minimize this entire part. So the task is to minimize this part, minimize this error, so that you can get learning in the good direction. So your inputs will be retain set, forget set, and your current model. This will be your input. So what will be your knobs, current knobs? So this is your learning rate, this beta, this like stability strength, because you want to stable, make your model stable, and this is lambda. So lambda is the forgetting strength, how fast you want to forget your model, how fast you want your model to forget the data. Now the objective, this part's objective is to retain the loss, this part is to forget the loss, this part stability, final objective is to minimize everything, objective is to minimize the loss. And then this is the optimizations loop, how you can optimize the entire scenario to get the best results. So based on that, you can maintain your stopping criteria and output related things, like you can stop when both folds, like forgetting achieved, like what you wanted to forget is achieved, and what you wanted to retain is also achieved, and your model is stable enough, you can stop. And for this you can apply gradient clipping, early stopping, trust region based scenarios, and then you will get results. Now there are some scenarios that I already discussed. So this is the entire concept of machine unlearning. So I hope that you will be able to understand this very simple topic. Thanks for watching.